Okay, to get you started with this question, I'm going to use some pointers. So here we're told this structure is going to be graphite. Now just to remind you, graphite is carbon atoms coming together in this structure. Okay, so that should help gather your thoughts. I'm just going to replicate that because this exists in layers, and in between the layers are these weak forces. Okay, so this is our structure for graphite. And another reminder, if we let's highlight just one of these carbon atoms in the structure. So let's pick on, say, this one, and this carbon atom, if I zoom in on it, is forming 1, 2, 3 bonds. And carbon, you should know, carbon atoms normally form 4 bonds. So it's only got 3 bonds. That should help you to explain why it behaves in the way it does. And something else to think about is these little red regions in between the layers are weak forces between the layers. So I'm going to suggest you do pause the video now, have a go at this question, and then once you've done the question, restart the video and the answers will be there for you to look at. Okay, so in terms of marking your answer, whenever you get a question about a structure, it's always good to draw a diagram. So make sure your diagram has been drawn and labelled so that people understand what you're about. Okay, now I've split my answer into 2 parts. This is going to be part 1, and over here we'll do part 2. Okay, so in part 1, we need to say that the carbon atoms are forming layers, and these layers are held together by weak forces, the weak forces in the structure. And this means these layers can slide. So these layers can slide past each other, and therefore it acts as a lubricant. So you get 1 mark for each of these bullet points, these bits of knowledge. In the second part of the question, we need to say that the carbon atoms are joined by covalent bonds. Each carbon atom is forming 3 bonds in the structure. This means there are delocalized or spare electrons which are free to move, and this is why graphite conducts electricity. So again, 1 mark for each of these. Now this question is worth 6 marks, so the way that you can think about it is if you got all 9, because 9 bullet points, if you've got all 9 bullet points, give yourself 6, and then 8 bullet points, 5, and so on and so on and so on as you go down the mark scheme. You can pause it again, check your answers, work out how many marks you got, and then move on to the next question when you're ready. Okay, so in this question we are being told that this circuit is used to test the ability of water, solid sodium chloride, and sodium chloride solution to conduct electricity. So here's my circuit, there's my power supply, then I've got a bulb wired into the circuit, and then here I've got my carbon rods. Now what they've not included in the model is this would all be sat inside a beaker, and in the beaker would be the substance that you are testing. So the 3 substances they're using, they would test it with water, then they'd swap it for sodium chloride, and then they would use sodium chloride solution. How would they know if these conduct electricity? Because they've got some results here. They would obviously wait for the bulb to light up, and if the bulb lights up, then this part of the circuit is conducting electricity. Something else you'll need to know to help you answer this question, just a reminder, the types of bonding present. So water is a simple covalent structure. Now that should mean something to you. Okay, so simple covalent substance. That should help think about the properties it would have. Solid sodium chloride, this is an ionic lattice. So again, that should help explain the result in terms of its ability to conduct electricity. Sodium chloride solution, this is an ionic lattice, but the ionic lattice has been dissolved. So again, that should help you to answer your question. My advice would be that this question is worth 6 marks. So let's split this into 3 parts. We've got part 1, talk about water. Part 2, talk about the results for sodium chloride. And then part 3, talk about the results for sodium chloride solution. So again, a bit of information to get you going. Pause the video here, have a go at the question, and then look at the answers, the mark scheme, once you have done that. Okay, answers to this question. So again, 1 mark for each bullet point you've included. So I've done it in stages as I described in the introduction. So the first one is water. And when you say that water is a simple covalent substance, this means the electrons are used in the covalent bonds, and there are no free electrons that are able to move. And this means it will not conduct electricity. So there's 4 points to include for water. Solid sodium chloride, so the second phase, is an ionic lattice. This means the ions are held in place by electrostatic attractions. The ions are not free to move, and therefore it will not conduct electricity. So there's 1, 2, 3, 4, 5 points in that question. Sodium chloride solution, we need to say that the ionic lattice has been broken when we dissolve the solid. This means the ions are free to move, and therefore it will conduct electricity. So again, there are 1, 2, 3, 4 points available for that one. In terms of overall marks, add up how many points you got. There's a total of 13 points, and then use this to work out how many marks you should be awarded. So if you got between 12 or 13, you get 6 marks, and then 11 and 10, 5, and so on and so on and so on as you go down the list.